Hello and welcome to this series about building a batch platform on Kubernetes. I'm Mofi, a developer advocate at Google focusing on batch and AI platforms.
I'm Ali. I'm a solutions architect, and I partner with Mofi in building batch and high performance architectures on Google Cloud.
In the previous video, we took a look at job, which is a fundamental building block in Kubernetes that allows us to run batch workload. In this video, we're going to take a look at another aspect of building a batch platform, monitoring.
So, for a batch platform, let's take a look at what we need to monitor. One aspect is the cluster health and the usage of its underlying resources. The other aspect are the jobs and the queues that are processing them.
One such tool in the Kubernetes world is Prometheus. Prometheus is a CNCF-backed monitoring tool widely considered to be the de facto standard solution for Kubernetes workloads.
Let's take a look at how it works. So at the core of it, we have what is called a Prometheus server that has an HTTP server built in, backed by a time series database, which is generally connected to some form of storage that can persist those metrics for long term. It also has a retrieval mechanism, but in a batch use case, since the jobs can end at different times, a push mechanism works better. So in this case, a push gateway exists so that each job can send its metrics down to the push gateway, and Prometheus can pull from the push gateway as just another stateful workload. Prometheus also has native service discovery for Kubernetes, and the metrics themselves can be visualized using Prometheus UI, Grafana, or any other number of API clients.
This works well for simple setups, but as your workload gets more complex, it becomes more difficult to scale horizontally. If we need to support more and more resources, we can scale our Prometheus cluster vertically by giving it more resources. When you have to manage multiple Prometheus server, managing multiple Kubernetes clusters, managing those Prometheus servers becomes a task on its own. In the open source community, people have been building tools to handle that kind of system, such as Thanos or Cortex or Mimir, to manage multiple Prometheus server to handle that complexity. So the simple Prometheus architecture we took a look a second ago turns into something more complex with many more moving parts and difficult to understand and manage.
This is where Google Cloud's managed service for Prometheus comes into play. This service can take all your metrics from your GKE clusters, compute engine VMs, and other VMs and take them into Google's planet scale time series database known as Monarch, which actually backs Google's own products like Search and Gmail. You can still visualize all this data using read clients like Grafana, Prometheus UI, and actually implement Prometheus rules as well.
For GKE and Kubernetes, you could use managed collectors and self-deployed collectors. And for any other environment, you could use self-deployed collectors to collect all your metrics using cloud monitoring ingest API into Monarch. You also have access to all free GCP metrics. Using PromQL, you could access those metrics to create Grafana dashboards, create Prometheus alerting, or any PromQL-based tools. Using Cloud Monitoring Query API, you could create SL alerting, cloud alerts, dashboards, or any future features that Prometheus will offer.
To recap, in a batch platform, we need to monitor two aspects. One is the cluster health and the resource utilization on the cluster, and the other are the queues and the jobs that are processing the workloads on the batch platform.
Once we have those metrics in Prometheus, we could create dashboards using tools like Grafana or any other tool that understands Prometheus metrics and create alerts. In the next video, we'll see a demo to see how all of this works in practice.